In the next two videos, we're going to be exploring different types of widgets that we can include in our user interfaces. Now see these videos as optional. I'm merely going to provide you some ideas as to the types of widgets you can include in a user interface, which you may find useful in projects that you embark on. So let's take a look at different Tkinter widgets that we can take advantage of. So firstly, we will import Tkinter, so we'll put from Tkinter import star, and the first widget we're going to be taking a look at is the button widget. So we'll first of all set a variable called root, which will set equal to a call on our TK class. To set a button, we simply need to create a variable, which in this example we'll call button, and we can then set this equal to a call on the button class. And this is the great thing about TK widgets. To utilize different widgets, it's simply just different calls on different widget classes that we then populate with arguments into the respective parameters. So the first argument we're going to pass into the button class is the app window in which we want this button to sit in. So in our example, it will be that root variable we've set above. We can then set a parameter called text, and we can set this equal to the text that we want to appear on the button. So in this example, I'll simply set the text to equal the string stop. Now we have many other properties we can set. For example, we can set the background color, the font color, we can set the height and the width of the button. So for this example, I'll simply just set the width to equal 25 for illustrative purposes. Now if I open up the documentation by pressing Shift and Tab, you can see that we have many other standard options as well as widget specific options, of which one of them is command. And this will instruct the button to perform some form of action once the button is clicked. So for this example, if I simply set the option command to equal root.destroy, when a user clicks on this stop button, the app will simply close. Now I'm not going to go into all of the options that the button provides, but it's very customizable and you should visit the documentation if you want to be more specific with your button styling. Now to get this button into the app window, we can then simply just put button.pack with parentheses, and if I now run root.mainLoop with parentheses and run this code cell, when I drag the application across, you can see that I now have a button labeled stop, and when I click on the stop button, the destroy method is called on our app window, which closes the application. Now we can obviously include as many buttons as we like, but the button is a very common Tkinter widget that you'll want to take advantage of. Next up we have the check button, and the check button will enable us to display a number of options to a user as toggle buttons, and the user can select one or more of these options accordingly. So to get check buttons into the app window, well, we'll first of all create an app window, so we'll call this root equals a call on the TK class. We'll then set a variable called var1, and we're going to set this equal to a call on the int var class. And what this will do is essentially create a value holder for integer variables, but I'm simply putting this for illustrative purposes. Now to create a check button, we can call upon the check button class, so we can put check button and then open parentheses. We can then pass in the app window in which we want this check button to sit, so we'll pass in root as the first argument. We can then decide what text we want associated with this check button, so I'll simply for the first check button put the text equal to the string turn on. I will then put a comma, and I can then have it so that the variable associated with this check button is equal to that integer value placeholder that we set above. So I can set variable equals var1 for this parameter. To place this turn on check button into the app window, I'll utilize the grid geometry manager, so I can put .grid, and then in parentheses, if we want this on the first row, we can set row equal to 0, and if I always wanted this check button to stick to the west side of the app window, I can set the sticky parameter to equal W. Now if I copy and paste these two lines of code and change var1 to equal var2, and then change the text of the second check button to be turn off, and we'll set variable to equal var2. To see our check button in action, I can now put root.mainLoop, and if I run this code cell, you can see that we're now presented with two check buttons one stating turn on, one stating turn off. I can have both deselected, I can have both selected, or I can have one or the other selected accordingly. Now once again, if I take a look at the documentation, you can see that we have many valid resource names that we can set for the check button. So we can set active background, active foreground, we have pad X, pad Y, width, height, foreground, the list goes on. So play around with these settings to ensure you understand how the styling and formatting would work for check buttons. Next up we have the label and entry widgets. So we'll set a variable labeled root to equal a call on the TK class. We can then generate a label widget, so to do this we call upon the label class. Inside the parentheses we can pass in the app window in which we want this to sit, so we can pass in root. The second variable we can pass in some text that we want to be associated with this label, so for this example I'll simply put first name. We can then place this in the app window by utilising the grid geometry manager, so if I put .grid and then want this in the first row, I can set row to equal 0. If I want a second label, I can copy and paste this line of code, and I'll change the text to be last name, and I'll simply have this label sitting on the second row, so I can set row to equal 1. We can now have an entry widget in which a user can type some information, and we'll have this sitting next to the label widget as an entry box. So we can then set a variable called E1, and once again we're going to be calling upon the entry class. Just like any widget, we call upon the respective class. So if I put entry and then in parentheses put the app window in which we want this entry widget to reside, so we can put root. I can then place this in the app window, so if I put E1.grid, and we want this to be in the second column, so next to the label widget in the first row, I can therefore set row to equal 0 as the first argument, and then I can set column to equal 1. If I copy and paste these two lines of code, change E1 to be E2, and then have it so that this entry widget sits on the second row, so changing row to equal 1. When I take a look at our app by putting root.mainLoop with parentheses and then running the code cell, you can see that when I drag our app across, we have our first label, which is first name, and then we have our first entry widget, which is placed next to the label widget here, and then we have our last name label, and then our respective entry widget next to it. So that's how we can include label widgets and entry widgets into our app. Next up, I want to cover the concept of a frame because we've only been working within one app window so far in these examples. So once again, I will create our master app window so we can set a variable called root to equal a call on the TK class. But now I'm going to include two frames inside of our app window. So I'm going to have a top frame in which we include 3 buttons, and then I'm going to have a bottom frame in which I'll include 1 button. So the buttons that we include in this app are going to be placed in 2 different frames. And the reason we do this is so that we can control them separately. So if I set a variable called top frame and set this equal to a call on the frame class, we can then specify what app window we want to place this in. And as we know, it will form part of our master app window, so we pass in root. I can then pack this frame into our main app window, so I can put top frame.pack, and this will now pack a frame into our main app window. We can then copy and paste these 2 lines of code, and rather than setting a variable equal to top frame, we're going to create one called bottom frame. And the only difference between the bottom frame and the top frame is where we place it in the app window. So I'm going to place this at the bottom of the app window. So inside the pack geometry manager, I'm going to pass in the parameter side and set this equal to the keyword bottom. Now we've set our 2 frames inside of our main app window, we can place widgets in them accordingly. So let's just place some buttons into both of these frames. I'll first of all create a button called rewind and set this equal to a call on the button class, and we're going to place this button inside of the top frame, and the button will have the text set equal to the string rewind. I'm then going to pack this button into the top frame so we can set the variable rewind and then access the pack method, in which we'll pack the side equal to left. So the rewind button will be on the furthest left. We can then copy and paste these 2 lines of code, and we'll create a button called stop. It will be inside the top frame. We'll set the text to equal stop, and then we'll once again pack it to the left hand side. So this will then go next to the rewind button after it's been packed into the top frame object. And finally, we'll create our third button so we can copy and paste these 2 lines of code once more. We'll set a button called fast forward. The text of the button will be fast forward, and once again we can leave the pack method so that it packs it to the left hand side. Now, let's suppose we wanted to put a play button in the bottom frame because we wanted to manage the play button separately. Well, we can copy and paste 2 lines of code from above. We can set the variable to equal play, and then we can place the play button inside the bottom frame rather than the top frame. So this is choosing what frame we want to place it in. I can set the text equal to play, and then I can state within the pack method that I want the widget to be placed on the side set equal to bottom. When I now run root.mainLoop and then run this code cell, and then drag the application across, you can see we have 3 buttons at the top, and they're placed within that top frame, and I can click on these respectively, and then I get the play button at the bottom within the bottom frame, which could be used in our application. Now notice here that when I expand and shrink the app window accordingly, the play button remains at the bottom within the bottom frame, and the top 3 buttons remain at the top in the top frame. Okay, so that's the frame widget, and you use the frame widget to compartmentalize your app into different sections so that you can then place different widgets within those sections respectively. Next up, we have the canvas widget, and the canvas widget allows us to incorporate and draw pictures and other complex layout-like graphics into our user interface. So for example, if I simply wanted to draw a straight line in our application, maybe as some form of divider, I can set a variable called root and set this equal to a call on the TK class. I'll set a canvas height, so canvas underscore height, to be equal to 100, and I'll set a canvas underscore width variable to also be equal to 100. I will then set a variable called y, and I'll simply set this equal to canvas underscore height divided by 2, and I'll pass this into the built-in int function to make it an integer. And the reason I'm setting these variables first is because I can utilize these variable values inside of our canvas widget. So if I now set a variable called w equal to a call on the canvas class, I can pass in root as the first argument. I can set the width of the canvas equal to canvas underscore width, which we've set above, so it sets it equal to 100. And I can also set the height of this canvas widget to be equal to canvas underscore height. Now you'll notice that when I put w dot and then press tab, we have lots of methods that we can call on this object in order to fill the canvas accordingly. So let's just say we wanted to create a line. Well, you can see one of the methods we can call is create underscore line. So if I select create underscore line and open parentheses, you can see that it takes in a number of arguments and keyword arguments, and the docstring states that it creates a line with coordinates x1, y1, and we can then set x2, y2, and so on. So in order to draw a straight line, we'll pass in 0 for x1, and let's just say that we wanted this line to be 50 pixels from the top. Well, we've set a variable called y above, which is just taking half of the canvas underscore height, so I can have our y1 coordinate to be equal to y. I can then pass in our x2 coordinate, which will be the length of the line from 0 to what we pass in as the third argument. So we'll simply pass in canvas underscore width, which is set equal to 100 as the third argument. Now, seeing as I want this to be a straight line, I'm also going to want the y2 coordinate to be the same as the y1 coordinate. So I'll once again pass in y as the fourth argument. If I now pack this object into the main app window, so if we put w.pack, and then we take a look at our app, so if we put root.mainLoop, You can see that when I drag the application across, we've drawn a line within our canvas, which is obviously very basic, but you can draw a lot more complex layout graphics in order to get your user interface looking exactly how you want it. So the canvas is great to use in order to draw pictures or incorporate other graphics that you so desire. Now the last widget that we'll explore in this video is the list box. And a list box is a way that we can incorporate a list of items and display it to a user, from which a user can then select the items accordingly. So if I set a variable called root and set this equal to tk, and then set a variable called list_box and set this equal to a call on the list box class, so list box and then parentheses, we can pass in the main app window, so we can pass in root, and then we can insert items into our list box. So if we put list_box, place a dot, and access the insert method, we can then pass in two arguments, with the first argument pertaining to the index value and the second argument pertaining to the element that we want incorporated into the list. So if we put list_box.insert and then pass in 1 as the first index, and we'll set this equal to the string golf, I can then copy and paste this line item 4 more times. We can change the indices to be 2, 3, 4, and 5 respectively, and then we can change the elements that we incorporate into the list box as we see fit. So for this example, if I change the second index to be the string tennis, the third index to be the string swimming, the fourth index to be the string football, and the fifth to be the string other, I can then pack this list box widget into the app. So if I put list_box.pack with parentheses, when I run root.mainLoop, run the code cell, and then take a look at our app, you can see that when I drag the app across, we have golf, tennis, swimming, football, and other listed in a list box, and I'm able as a user to select the item depending on what this relates to in the user interface. So there you have it, a few widget options available to you. I hope this has given you some ideas. We're halfway exploring some of the main Tkinter widgets, so I'll see you in the next video where we cover some more.